There are enough eyes. In fact, we want to use that as because that actually some contamination got in there, and that's now starting to go. That's all right. So let's see what we have here. All right. So there we see all of the extrinsic eye muscles. So in chapter 13, we just talked about the fact that we've got several cranial nerves running to these muscles. Now in chapter 15, we will name these 6 muscles. All right, and you can actually see the muscles right there. All right. There's also a lot of adipose around there. And what is the function of the adipose? On the eye, around the eyeball.
Cushion?
Yeah, cushioning. More, not so much energy as opposed to cushioning. All right. And then here on the back side, right there, is the optic nerve. So there you can see the optic nerve right there. Oops, right there. Which we saw nicely on the sheep brain. Right? So it comes out right there, runs along, crosses that optic chiasma, and then ends up in the occipital lobe. Right? So there's that. Right? Now, let's tilt it forward, and there we can see there's the cornea. Right there. Alright? Now what I want you guys to do here now when you're done with this is look at the side of your colleague's eyes, like that side view, and we'll see a cornea. But it's not a prominent cornea. Humans, it doesn't stick out that far. And the cornea is colorless, clear, like glass. Right? If you have a dog or a cat, even better. Dogs on the side, real. And it's clear, folks, because we are alive. Right? Here is the sheep cornea. Notice what is the color of the sheep cornea. It's now become opaque. It's clouding over. Right? So as soon as we die, it starts to cloud over. Right? Okay? The white is the sclera. So there's the white, the sclera of the eye. And notice what happens. The sclera is where my muscles will attach to. Okay? And then when I feel the sclera, it is pretty sturdy. And notice it is that tap on there behind you? Is it?
No, it's just the ice.
It's the ice. The sclera is white. Strong.
Like the Duramato.
Yeah. So made up of what? Lots and lots and lots of collagen. Because again, you think about what is the function of the sclera. Right? Protect the structures inside, muscle attachments, so dust particles hit the eyeball, sclera not going anywhere. Right? And you actually see here, so I'm going to go ahead and cut this open here. Now the other thing too, for those of you, if you are going to dissect the eye, just feel, and you'll actually feel intra-orbital pressure. So there's pressure inside, and it's going to be water pressure, so it's hydrostatic pressure. So there's water in there. All right? So let's go ahead. Hey?
If you poked it, it would drain out.
Yeah, so, and again, so the sclera plays a big role, and there you can actually see some of the water squeezing out, folks. That is the watery component of the eye, and that is called the aqueous humor. So we're going to see that the water is of 2 formats. The water is watery. Let me just try and see if I can save that. So it's watery like that, or it is going to be jello-like. So watery, aqueous humor, and that's going to be in front of the lens. And now notice how I use the language. Aqueous humor, water in front of the lens. The jello, vitreous humor. Let me just put this in my hand. The water, vitreous humor behind the lens. And notice there, I actually have to bite pretty hard with the scissors to cut through the sclera, because it has so much collagen. Very, very strong structure. Okay, there we go. Right, so there now is right there. Okay, so there we go. So now we can see right there. There's my lens right there, folks. And there is the jello vitreous humor. And notice where's the lens located? Right behind the pupil. We're going to see the pupil here. Now notice we couldn't see the pupil because the cornea was clouded over. Alright? And that is the retina right there that we're going to see. Right there. Alright, so let's do this part first. So there, That is my aqueous humor right there, water, and there is my vitreous humor, which is the jello, which is actually going to stick to the lens. Ay, 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 all right, there we go. Okay. And part of this is these eyes are just way, way old. So there we can see there's the lens right there. And the jello, the vitreous humor will actually stick onto the lens like that. So water, aqueous humor, jello, vitreous humor, and there's the lens. Now, in us who are alive, what is the color of the lens? Clear. But as soon as we start to die, the cornea, notice there's the cornea. Let's put in the light. There's the cornea. It starts to also cloud over. Right? So let me pour this down here. Right, so there's the jello right there. Okay, now let's have a look here, folks. So there we can actually see. So now we tilt it back, and there we can see behind the iris. There's still a lot of jello right there.
Because it's old.
Yeah, and it's also starting to go bad there. You can kind of smell in there, and it's not. I'm not real happy there with that. So we've had it for like a couple of years. So notice right there, folks. There is the back of the iris, right there.
The black.
The black is the back of the iris. So notice it's reflecting through the cornea there as what? The browns or the greens. Right, now remember in your groups also you want to look at your colleagues' eyes. Alright, Ms. Harris over there, big differences in her eyes. So Rachel, if we're not quite sure, colleagues are just going to come and look at your eyes if we can. Because we didn't even have to shine the light on there, the flashlight, because in the light over there, the contrast between her inner and outer is huge and clear, brown and green. Right? So we can see that. Okay? Then notice right there, folks, what is that hole? What is the hole?
Pupil.
The pupil. Right? And notice, if we hold this up to the light like this, right?
How come the pupil's black on us, though?
No, the pupil is colorless.
It's
Oh, in,
not clear.
oh, in ours? Well, why does it look black in us, folks? Because of the melanin behind it. Yeah? So you can see right there.
So it's actually clear.
Yes, if I cut your eye open like that, then if we tilt it up like that, then we're going to see the hole right there.
So would mine be blue on the inside?
No, black.
No, I mean not the pupil, the iris.
So the iris here, you see what's happening, folks, is, yeah, so there's melanin right there, which is what color?
Black.
Black. But there's no black. But there's the cornea, and what is happening now is, and there's water, right, aqueous humor, so that is reflecting through, right, it's coming through. So who's looking at that black melanin is me, right? And what is happening is I'm looking through the cornea, I'm looking through water onto black melanin. But because there's so much melanin and the reflection comes back at me as brown, yes? Then if there is less melanin, I'm looking at that again, and now what is happening? The reflection coming back at me is blue. Yes? Okay? Right, so there we can see that. Now, let's look at this here. So there now is, that is the retina. And notice the retina is this creamish material. And what cells do I find on the retina? The rod and the cones. Now, can I see rods and cones on that? No, this is macroscopic, that is microscopic. Now, what I want you to see, folks, this is real neat here. All right, there is the optic nerve right there. There's the optic nerve right there. Right there. Right, if I can just grab onto it. There's the optic nerve right there. Everybody good? Yes? And this is what I'm going to do now. I'm going to pull the retina like that, and it's actually going to get stuck on what structure right there? The optic. No, inside the eye. No, it's not the indentation. Indentation is right behind the pupil. So what structure is where the optic nerve leaves the eye? The optic disc. So there's the optic disc right there. So notice right there, that's where so what is not located at the optic disc? The optic one right there. There's no rods and cones right
What's that
there.
blind spot?
That's the blind spot right there. You can see. So all of what I have in my hands are millions of rods and cone cells. And they all going to the nerves run out right there at the optic disc. All right? So let me pull that out of the way. Then this is the choroid right here, folks. There's the choroid, the black. And then we see this iridescent structure right here running through there. And that iridescent structure is called the tapetum lucidum. Tapetum lucidum. Tapetum lucidum. And the tapetum lucidum is actually going to be an area where light is going to be absorbed. So what is that going to help with?
Color.
No, with sight. And this actually becomes very important in darkness. So an animal like this that has the tapetum lucidum is able to see better than me that does not have a tapetum lucidum.
Is it always blue?
It's going to be iridescent. Iridescent. So sometimes blue, but most times it'll be that mother of pearl color. That mother of pearl color. Yes? All right. Let me, like I said, these eyes, they actually stink. So let me cut this one open here.
Yeah, it looks a little green in there.
Right, let's see. Oops. Sorry. Did you get on?
I wish I would have got that.
Sorry. Sorry, ladies.
Little eye juice.
That's right.
These are sheep eyes right there in the bucket right there. And something is going on there because it's starting to actually, go bad.
Where you're from, is this like a delicatessen to eat? I
No.
know some people eat them.
Yeah, that very, very soft, the muscle.
Do you eat them? Like
Yeah,
liver?
oh yeah.
I'm really hungry.
These have gone bad, sorry.
Andrew Zimmern.
And they're
Andrew
probably-
Zimmern. Andrew Zimmern. I love the TV show Andrew Zimmern. I don't know if you guys, I think it's a Discovery Channel,
Cool stuff.
eat some delicious looking things. I'm like, man. Right there, you can see the iridescent right there. So most times it's going to be like that. That iridescent mother of pearl is called the tapetum lucidum right there. Right there.
When like dogs, they don't see color. Do they not have as many Is it cats? Cones.
With cones, again, animals that like insects and other, like they will have more rods, or the cones won't be as effective as us. Now remember, they do see
Gray.
infrared, so they, in us, we see all colors of the rainbow.
What about like a nocturnal animal? Would that be?
Will be bigger.
Yeah.
And look at an animal like a nocturnal, like take the owl for example. Notice what happens with the size of the pupil in the owl. You look at the eye and it's black. Well, it's not really black. What has happened, the pupil has just opened up, dilated like that to allow whatever little light there is in the dark in so they can see.
Is that what we see when like deer in the headlights, like when it's like they're like really like shiny?
It could
Is that what
be,
you see?
sure it could be that you're seeing reflecting back because light is then hitting back. Right? All right, folks, continue on. And again, like I said,